Chapter 7-3, logarithmic functions. Graph the function y equals 2 to the x by making the x by table. Get on time.
Sorry.
If I have x equals -2, -1, 0, 1, and 2, and I want you to plug and shove, you tell me, how do I do that? That's going to give me 2 to the -2. And what's 2 to the -2?
-4.
No.
4.
1/4. 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the first is 2. And 2 squared is 4. It's negative exponents. We've been talking about this for a long time now. It's my only class not getting that still. Okay, now if I graph those points, -2 and then 1/4 gets me so close to the x-axis. Then -1 to the half, and then 0 to the first, 1 to 2, 2 to the 4. Do you see my ordered pairs that I just graphed on there? Now, the exponential function takes this shape that gets very, 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 very close to the x-axis, curves up, and looks like a growth function. Do we all see that? It's increasing growth exponential function. Now, what I want to know is what is my domain, my range, and my asymptotes to this. Now, what do we know about asymptotes?
It never touches the x-axis.
It never touches the x-axis. So if it never touches the x-axis, which is a wonderful concept, the x-axis is which one? The vertical or the horizontal? Horizontal. Now, do you remember back in the day, way, 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 way back, all the lines that looked like this had x and y in them. All the lines that looked like this was y equals a number, and all the lines that had undefined was x equals a number. Do you remember that slope picture from way back in the day?
Yes.
Okay, so if you're telling me that this exponential function has a lovely asymptote at the x-axis, what is the equation of that horizontal x-axis? Y equals 0. So I have an asymptote at the equation y equals 0. In other words, it gets really close to it, but does it ever touch it? No. Excellent. So now I need to talk about my domain. Does domain deal with the x or the y values? It deals with the x values. How do you read your x values? From left to right or up to down? Up, bottom to top? From left to right. So as you're reading this thing from left to right, I'm clear out here and I'm hopping along here. Is there a corresponding y value to where I'm at every spot there? Yes. And if I keep walking along here, and I'm right here now, do I have a corresponding y value? Sure. It's way up here. It's increasing. And how about as I go over here? Do I have a corresponding y value? Yes. It's an increasing function, meaning it's going up. Do we understand that? Now, my question is for you. Are there any holes in this graph that x is not allowed to be? No. So what is the domain of this function? X can be any real number. Very good. So x is an element of reals. Now, how do I read the range? If I'm reading the domain from left to right, then my range is going to be from bottom to top. So as I am walking up this vertical line, is there any corresponding values here? Where do I run into a graph? I don't run into a graph until I get to where? The x-axis. But can it be the x-axis? No, because the x-axis has what on it?
Percent function. No, it's not.
It has an asymptote on it, which means it cannot touch it. So what values can y be? Where does it start at?
From 0 to 1.
From 0 to where?
0.9.
All the way up to infinity. So y can be any value as long as it is greater than 0. In other words, I have values. As I'm walking along here, I can see a y value. As I'm walking along here, I can see a y value. Do we understand that? So as I'm going up there, I have a y. Yes. I have a range starting at 0, but it cannot be 0, but it has to be greater than it. Do we understand that concept? Okay, now, the second one that you have here is just me graphing y equals 2 to the x for you, so that you can see a nice graph and nice ordered pairs. And my question to you is this a one-to-one function? What's it mean to be one-to-one?
Every X has its own Y.
Every x has exactly one y, and every y has exactly one x. Remember, this was the Baskin-Robbins example? What's your favorite ice cream, Tiffany? Chocolate. That means chocolate can only be Tiffany's ice cream. Nobody else can choose that tub. If chocolate goes to her, and she chooses chocolate. Do you remember that? Okay? So that's what that means. Okay? So if it is a one-to-one function, what does that mean? Is this a one-to-one function?
Yes.
How do you know?
Because there's no repetitive school laws.
Meaning it passes what?
The one the vertical line.
The vertical line test. Meaning this thing passes the vertical line test. Meaning for every x, it has chosen exactly one y. So yes, this is a one-to-one function. What's the significance of being a one-to-one function? Why is it important to be a one-to-one function?
Because it's a vertical.
If you are a one-to-one function, then what exists for you? Starts with an I.
ISO.
Starts with an IN.
Intelligence.
You have what? You have an inverse. So if you are a one-to-one function, then what that means is there is an inverse out there somewhere, and you can locate it. Well, how do I go about doing that? Let's think about that a minute. If 2 to the x has an inverse, well, what does that mean to be an inverse? What happens to your xy table?
It switches.
They swap out. Excellent. So my x's up here were -2, -1, 0, 1, 2. So down here, they become my y. Do we see that? And my y values, which were going to be 1/4, 1/2, 1, 2, 4, now become my x values to be 1/4, 1/2, 1, 2, 4. Do we see that? Now, can I plot these points?
Yes.
Sure, so let's plot them. So at 1/4, I am going to go down to -2. At 1/2, I'm going to go down to -1. At 1, I'm going to be at 0. At 2, I'm going to be at 1. And at 4, I'm going to be at 2. Well, do you see my lovely little ordered pairs there? If I connect those dots, what do they look like?
One-armed bandit.
It kind of looks like the one-armed bandit. The one-armed bandit is what I refer to as the square root function, right? Okay? But this is not a square root function. This is a logarithmic function. This is what we call a log function. Okay?
Is there a long button?
There is a log button on the calculator that you guys are going to soon learn how to use. Okay?
Good.
So this is the log function or logarithmic function. And my question to you is, since it's an inverse of an exponential function, what is now my domain reading it from left to right? I'm right here on my x-axis. Do I have a corresponding y value anywhere? No. I'm right here on my x-axis. Do I have a corresponding y value anywhere? No. Now I'm right here on my x-axis. Do I have any corresponding y value? No. When do I run into a corresponding y value? After I cross the value what for x?
0.
0. So what does that imply about x value? It can't be negative, which means what does it have to be?
Positive.
Has to be greater than,
0.
has to be greater than 0. Can it be 0? Why can it not be 0, Maddie? Because what's happening down here?
It never touches really close.
It never crosses. It gets really close to it, which means I have an asymptote there. And what is the equation of the asymptote? What is the equation? If my horizontal asymptote was y equals 0 for my exponential function, what will be my asymptote for my logarithmic function? It's x equals 0 because it's a vertical asymptote. Do we understand that? And vertical lines have the equation x equals a number. Do we get that? Okay, well now let's talk about your y values. Well, I want to talk about y as I am right here. What's happening to my y values? Do I have a corresponding x? I have one, don't I? What about as I get bigger? Do I still have one? Do I still have one up here? Do I still have one all the way up there? Are there any restrictions on y? So what can y be? It can be anything it wants to be. So y is an element of the real. Maddie, are you good to go now?
Yeah.
Okay, thank you. Now, let's look at this a minute. I told you that a logarithmic function and an exponential functions are what? Starts with I. They're inverses. So if they're inverses, that means if I go back to the very first slide and scroll down here, my domain of x and the number of reals now becomes what?
Y.
The what?
The Y.
The y value is over here, which is the range. So y is the number of reals. Do they match? They match. So if I come back up here, my range, which is y is greater than 0, now turns out to be what? My x values, which is going to be my domain over here, and x is greater than 0. Do they match? If I go back to the first one up here, I have a horizontal asymptote at y equals 0. If I come back to this one, now what do I have? A vertical asymptote. Now, the equation of this function is going to be log base 2 of x. Those two functions, which are right here that I graphed so beautifully for you, 2 to the x and log base 2 to the x are going to be inverses of each other. Now, if you're inverses, what can you tell me about these two functions? Reflected over what, please?
Y. No, not reflected. It's a translation. It's a rotation. Translation.
It is reflected over a line, a very special line.
Diagonal line. I don't know. Line of symmetry.
What is that line? That goes through the origin and has a slope of 1.
Origin line slope of 1.
That has a slope of 1 and goes through the origin. So it's reflected over the line y equals x. In other words, if I put it on that line, what's going to happen to those two functions? They're going to lie directly on top of each other, which means that's what you have. That is the line of symmetry y equals x. Okay, so those two functions are inverses. Do we understand those two functions in the beautiful graph that I gave you there? I put those graphs there because we all suck at drawing, and it's nothing nicer than to see a beautiful function that looks like that. Right? I'm not, so I'm not going to lie about that. Okay, now this whole page, here's what you need to have that's highlighted. Now, I had to put this page in here because there is a whole bunch of junk that goes with it. There is. It's really important. Good snag. Log base b of x is equal to y if and only if b of y is equal to x. What does that mean? And if and only if means it goes backwards and forwards. It can be read both ways. It can be read both ways. Notice this. Look at the bases. Log base b of x is equal to y implies that b to the y is equal to x. Now that's all very, 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 very important. However, what's more important is this, translations. Now, let's see if you all remember this. If my parent function is y equals 2 to the x, what happens to this function? It's going to go to the left 3 units. What happens to this function? It's going to go up 4 units. What happens to this function?
Y.
It's reflected over y. And how about this?
It's compressed. No, it's not.
It's a stretch of 3. Now let's take that same philosophy, and this time my parent function is log base 2 of x. Now, what's going to happen to this one?
Down 3.
It's going to go to the left 3 units. What's going to happen to that one? Are there parentheses?
Up.
There are no parentheses, so therefore it goes up 4 units. What happens to that? It's reflected over the y. So what am I implying here? That they are exactly the same concept. So if I look at this lovely little graphic that I gave you, everybody on this page in your packet, if I look at this point right here of my parent function, which is going to be the point 1, 0, go to the one to the right of it, what happens to the x plus 3, 1? Well, this is where it was, but now I'm moving it 1, 2, 3 units to give me the point negative 2, 0. Well, how did I get that? I took 1 minus 3, which gives me negative 2, 0. Do we see that? The x is what changed. The y did not. Go to the bottom green one here. I have log base 2 of x minus 3. What it was at 0, 1, now what do you think happened? It went down 1, 2, 3 units, so therefore I'm at the point 1, negative 3. Well, what changed this time? The y value changed. To get that, I took 0 minus 3 to give me 1, negative 3. Do we understand that? Now go to this one right here, the orange one. Log base 2 of x minus 3. What's going to change, x or y? The x changes because it's in parentheses. So that means it was at the point 1, 0. Now I'm going all the way to the right 3 units, which means I'm going to take 1 plus 3 to give me the point 4, 0. Do we see that, yay or nay?
Let's say it's higher.
But it's not. I promise. Because it's curved. Okay, now over here, I have 1/2 times log base 2 of x. Well, it's a compression. What is compressing? If you compress your trash, you're putting it down, which means the 1/2 is moving it closer to the x-axis, which means it's compressed. Okay, the 3, I have 3 times. That means I'm making it larger, so how do I do that? I'm stretching it out, meaning I can have more things in there, so this is going to be a stretch. And this is typically 0, 1, but it's a reflection to make it negative 1, 0, right? And then over here, it was supposed to go like this, and then they reflected over the x to go the other way. Do we all see that there, yay or nay? I promise you, you will have something like this on the quiz. I made the quiz. I promise you, this junk is on there. You better know it.
What's the first 2 of the left?
This one? This is the parent function.
Well, is it stretch and
No, it's just normal. Okay? Okay, now, evaluating. Evaluating is one of the most important things that you're going to do with a logarithm. Okay? If I have log base 8 of 32 is equal to x, the first thing you're going to do is find the base. The base is going to be the lovely little number that is right attached to the log. So what is the base? 8. That 8 becomes the base on your exponential function. So you're going to leave a little space and put an equal sign. And then the base b of the log is the base of the exponential. We talked about the exponent is a cross equal sign. So what's a cross equal sign? X. So that's what becomes the exponent on the 8. And then what is equal to, we're going to drop down this 32. So 32 is what goes there. Now here's the thing. Is 8 a prime number? No. Can I express 8 as a prime number?
Yeah.
A prime number to a power. What prime number to what power is equivalent to 8? 4 is not prime. So 2 raised to what power is 8? 2 times 2 is 4, times 2 is 8. So therefore, 2 cubed is 8, and I tack on that lovely little x. Can I express 32 to have exactly the same base?
The base,
Yep. So what number, 2 raised to what power is 32? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is...
32.
So 2 raised to what power is 32? 5. So what this means is I have 2 to the 5th is 32. Now, if your bases are the same, what can you conclude about your exponents? That they're the same. So what this means is I can basically ignore the bases, and I have 3x is equal to 5, and what do I do? How? I hope you all are writing this down because I will not go over it again with you by yourself later on if you refuse to write anything down. Now, what does that 5/3 mean?
It's a fraction.
It means that the log of 8 of 32 is 5/3. That's the answer. That's what that means. Now, next, log base 5 of 125. Well, do I have what it equals? Can I add what it equals? Can I put an equal sign there? I don't know what it equals, so I can put x, right? Why not? So now what's my base? Your base is 5, so that becomes the base of my exponential. So I have 5, leave a space, write the equal sign. What's the exponent on the 5? Look across the equal sign, that becomes x. And then where does the 125 go?
On the other side.
On the other side of the equal sign. So is 5 a prime number?
Yes.
Yes, 5 is a prime number. How about 125? No, can I write 125 as 5 raised to a power?
Yeah.
Well, 5 times 5 is, how many quarters equals $1.25? 5. So 5 what? 5 cubed. No. 5 times 5 is 25 times 5 is 5 quarters. 5 quarters in your hand.
I was getting confused, there's too many fives in there. Yeah, you really got me.
That's because you aren't thinking logically. X is equal to 3 because I can ignore my lovely low bases. Now, with that said, what does this imply?
That's the answer. Log 5, 1.5.
Excellent. Okay, this time there's no exponent, there's no steps there, so what do?
Set it equal to x.
Set it equal to x.
And add 4.
4 is your base,
X.
equals 32. Is 4 a prime number? A number divisible by itself in 1 only. That's a prime number. So is 4 a prime number? No. Can I write it as a prime number to a power? What is it?
2 and 2.
So 2 squared times x is equal to what's 32? We just did it a little bit ago.
4. 6.
2 to the 5th. So now my bases are the same, so what can I do?
Cross out the
So x is equal to 5 over 2. Okay, next. What do I do?
Set it equal to x.
Set it equal to x. 64 to the x is equal to 1 over 32. Now what is so ugly about this thing?
Fraction.
The fraction. So can I make it not a fraction?
Yeah.
How? 32 is in the bottom of the fraction with a power of 1. How can I put it to the top?
-1.
To the -1. Excellent job, Nick. So 64 to the x is equal to 32 to the -1. So now I no longer have a fraction, which is what we don't like. Now, can I express 32 differently?
Yeah.
What is it? 2 to the 5th. Which is going to be 2 to the -5. Wait,
I think you just put, like, I think you just put negative on it, doesn't change the answer.
red poster right there. X to the -n is equal to 1 over x to the n. So if I have 1 over x to the -n, it's going to be equal to x to the n. You can put it any place you want. 1/2 is the same thing as 2 to the -1. They're exactly the same thing.
So you can just put it right
1/3 is the same thing as 3 to the negative 1.
So if we put that on a problem, then you're not going to write problem.
Depends upon what I ask for the instructions.
Or if you don't have to.
What if, what if, what if? Let's do this one.
That was just a question.
I know. 64. Can I express 64 as a base of 2 to a power?
2 to the
Well, 2 to the 5th is 32. What's 2 to the,
6.
which would be 64. So 2 to the 6 times x, so this is going to be 2 to the 6x is equal to 2 to the negative 5, and what can I conclude?
Cross out the
6x equals negative 5, so x is equal to negative 5, 6. Okay, now I have one last concept here that's important on this. If I have log base 10, I don't like to see log base 10 because log base 10 is very redundant. It's like saying 1x. Do we like to see 1x?
Yes.
No, what would we rather see?
2x.
Just x. If I have 1x, it's the same thing as writing it as x, correct? So every time you see log base 10, you can write that as log of 1,000. The 10 is understood to be there. So if you're missing a base, if you have no base, then it is understood to be 10. 10 is what they call the common log.
0.
Because back in the day, they said 10 is the common log. I chose 10. Why don't you guys do your homework? I don't know.
I do my homework. I do.
So now, if I set this thing equal to x, how do I solve this? What's the base? It's not there, so what's it understood to be?
10.
So this is 10 raised to the x power is equal to 1,000. Is 10 a prime number?
No.
No, but what are the factors of 10?
5 and 5.
5 and 2 are those prime numbers?
Yes.
2 and 5 are both prime numbers, so can I do anything with that?
No.
No. So now can I express 1,000 to a power of 10? 10 to what power? 10 times 10 is 100 times 10 is 1,000. So 3 10s multiplied together give you 1,000.
What's 10 to the 10?
Is that our problem right now? Stay on task. So now, the exponents are equals. My bases are the same, so I can set my exponents equal. Do we see that? What was the point of this problem? To show you that if you have a base of 10, it's understood that it is 10 if there's nothing there. Okay, now we're going to go backwards. Instead of writing from a log to an exponential, we're going to take an exponential and write it as a log. So now, pick out the base. What's the base? The base is 10 because that's what has the exponent. So immediately you're going to write log base 10 is equal to, where does the exponent go? Across the equal sign. And then where does the 100 go? It drops down. Now, do I like to see log base 10? No, what should that be? Log of 100 is equal to 2. Do we understand that? Yay or nay? Okay, what do I do here? Find my base. Your base is 6. So now what do I write? Log base 6, leave the space, write the equal sign, and what goes across the equal sign? The power, which is 2, and what drops down? 36. That means 6 squared is 36. Do we understand that? Okay, what about this one? What's your base? 3. Your base is 3, so I'm going to immediately write log base 3, leave a space, write the equal sign. 0 goes after it, what drops down? 1. Now I want to talk about this 3. How important and relevant is that 3?
Not very important.
Why? Because anything to the 0 power will always and forever be what value? So could that be log base 5? It could be log base 5 of 1 is equal to 0. It could be log base 10 of 1 is equal to 0 because you're taking it to the 0 power. Okay, what about this one over here? How do I write that? What's my base?
2/3.
2/3 is your base, so log of 2/3, leave a space, and you put an equal sign, and what's my power? And what drops down? 8 over 27 written big. Do we understand this? Excellent. Now this brings me to our next concept, which has an E. What's my base there? E, but what is E? 2.718. So my base is E, which means I'm actually going to write log base E, leave a space, is equal to 2. What drops down? 7.39. Now, I have a problem with this. Just like log base 10 was the common log, I don't like to see log base E, because log base E does not exist. What you really need to write, log base E turns into ln of 7.39, which is 2. What that's called is the natural log. So when you see log base E of x, that's the same thing as saying natural log of x. Natural log. Why do they write it as ln rather than nl? I have no idea, nor do I care. I just do it. It seems appropriate. I'm sure you would. Okay. Now, this right here, logarithmic scale. The scale used on the logarithm of a quantity rather than the whole quantity. In other words, I'm taking the log of the quantity and putting it on a scale rather than taking the humongous large quantity. Does that make sense? And we're scaling it down. They use this for the Richter scale. What does the Richter scale measure? Earthquakes. It does, okay? So we have our magnitude, and then we also have our energy released. Now, why is this important? Everybody get their books open to page 453 if you have them. This slide right here is on page 453.
Do you remember that earthquake?
Sure, I do actually.
Okay,
Now, in December of 2004, an earthquake with magnitude 9.3 on the Richter scale hit off the northwest coast of Sumatra. The diagram shows the magnitude of an earthquake that hit Sumatra in March 2005. Now, this diagram right here, that was in 2005. So it had a magnitude of 8.7. Do we see that? Yay or nay? That is an 8.7. That's how far it went out. Do we see that? Now, and in 2004, you had a 9.3. So was that larger or smaller? My question to you is, how many times larger was that one in 2004 compared to this one in 2005, 8.7? So the formula that you're going to use to compare them is going to be the log of I sub 1 over I sub 2 is equal to m1 minus m2. And this compares the intensities, okay, of the earthquakes, where I is the intensity level by a seismographic, m is the magnitude. So all you're going to do is you're going to plug and chug, okay? So if I take this formula, log of I1 over I2 is equal to m1 minus m2. Well, what was m1? The magnitude of the very first earthquake. What was the very first earthquake? No, it wasn't. The first earthquake was 9.3. What was the magnitude of the second one, which is M2? 8.7. And that whole thing is going to equal the log of I1 over I2. Now, if I have $9.30 and I give somebody $8.70, how much money do I have left? 60 cents. So log of I1 over I2 is equal to 60 cents. What is the base of this thing? What is the base of that log? Why is it 10, Marissa? There is no base, so the base is understood to be 10. So how can I write this thing as an exponential? Base of 10, look across the equal sign, get your exponent, is equal to, bring down the ugly. What does the I1 over I2 mean? The intensity of the first earthquake divided by the intensity of the second earthquake. Does that make sense? We were only given the magnitude. Were we given the intensity? No, we were only given the magnitude. So we want to know what is the difference of this intensity. In other words, how much greater was the other one? So if I plug that into my calculator, 10 to the 0.6 is what? 3.98. Do we see that? So if that's 3.98, That is equal to my change in my intensities. How many times greater was my earthquake in 2004 versus 2005? Which is approximately 4 times greater. Do we understand that? Yay or nay? Okay, let's go to this one. In 1995, an earthquake in Mexico registered 8 on the Richter scale. In 2001, an earthquake of magnitude 6.8 shook Washington State. How many times more intense was the 1995 earthquake than the 2001 earthquake? Well, what's the formula? Equals M1 minus M2. Well, what was the initial? What was the first magnitude on the Richter scale? 8. And what was the second one? 6.8. So if I have $8 and I give somebody $6.80, how much money do I have left? $1.20. You can tell you don't work in a restaurant. Now, how do I get rid of that law? What's the base? The base is understood to be 10. That 10 is there, so I have 10 to the 1.2 is equal to my intensity comparison. So if I go back over here, 10 to the 1.2 is the same thing as 15.8. So how many times larger was this? So this was approximately 16 times greater. Did we see that? Yes or no? Okay, well, tonight for homework, I got to every single thing on this worksheet for you, except for your pH problems. Your pH problems are 29 through 32, okay? So tomorrow, what we're going to do is you guys are going to go over the pH problems with you in class, okay? And then tomorrow, you guys are going to take a quiz over 6-1 or 7-3 at the end of class, right? So tonight's homework is everything except for 29 through 32. Any questions?